friends, in this video we will start the miscellaneous exercise for the complex number, that is from the question number 2 to 19, and the remaining question will be in the next video. Now let us start the miscellaneous exercise. Now the question number 2. Solve the following equations for xy belongs to set of real number. First is 4 minus 5i bracket complete into x plus 2 plus 3i bracket complete into y is equals to 10 minus 7i. Now 4 minus 5i into x plus 2 plus 3i into y is equals to 10 minus 7i. Normal multiplication is there. Therefore, the terms, real part terms, that is the 4x plus 2i, and the terms with imaginary numbers, that is a minus 5x plus 3y bracket complete into I is equals to 10 minus 7i. Now equating the real and imaginary part, we get respectively, we get 4x plus 2y is equals to 10 minus 5x plus 3y equals to minus 7. This is equation number 1 and 2. Multiply equation number 1 by 3 and 2 by 2. Therefore, the variable y will be the cancel. Multiplying with by 2, you will get 3. That is a 12x plus 6y is equals to 30. This is equation number 3. And equation number 4. 10x plus 6y minus 14 equals to, that is a 4. Now equation 3 minus 4, that is a 12x plus 6y is equals to 30. And next is minus 10x plus 6y is equals to minus 14. And that's why you will get, that is a, the term is plus sign is there, must be there. And that there is a minus sign, but it is a plus. That is a 22x is equals to 44. Therefore, x is equals to 2. There is a plus sign. Therefore, x is equals to 2. Put x is equals to 2 in equation 1. Therefore, 4x plus 2y is equals to 10. That is a 4 into 2 plus 2y is equals to 10. 8 plus 2y is equals to 10. Then 2y is equals to 10 minus 8, that is equals to 2. And therefore, y is equals to 2 upon 2 is 1. Y is equals to 1. The value of y is 1. I am changing it. Therefore, x is equals to 2 and y is equals to 1. Next is, now we see the question number 2. That is x plus iy upon 2 plus 3i is equals to 7 minus I. X plus iy upon 2 plus 3i is equals to 7 minus I. Now there cross multiplication, that is in bracket 7 minus I into 2 plus 3i. Now perform the multiplication, that is 7 in bracket 2 plus 3i minus I in bracket 2 plus 3i. Now perform their multiplication, that is a 14 plus 21i minus 2i minus 3i square, that is a 14 plus 19i minus 3. I square means what? Minus 1, and minus minus become plus, and you will get that is a 14 plus 19i plus 3, and that is a 17 plus 19i. Therefore, the value of x is 17 and the value of y is 19. Equating the real and imaginary part. We get x is equals to 17 and y is equals to 19. Now next is third part, x plus iy into 5 plus 6i is equals to 2 plus 3i. X plus iy into 5 plus 6i is equals to 2 plus 3i. Now x plus iy is equals to 2 plus 3i, that is a 5 plus 6i will be get divided to the right hand side because it is a multiplicative. Now see this division how to perform, that is a multiplied with its a conjugate, the conjugate of 5 plus 6i. That is 2 plus 3i upon 5 plus 6i into 5 minus 6i upon 5 minus 6i, and that's why you will get that is a 25 minus 36 I square, and that is their multiplication, that is a 2 into 5 10 minus 12i plus 15i minus 18i square, 25 minus 36 into minus I, that is a 10 plus 3i minus 18 in bracket minus 1, 25 plus 36 and minus 18 minus 1, that is become plus upon 25 plus 36, that is a 61, and 28 plus 3i upon 61, and that's why you will get 28 upon 61 plus 3i upon 61. X plus iy is equals to 28 upon 61 plus 33i upon 61. Now equating the real and imaginary part. Separately, we get x is equals to 28 upon 61 and y is equals to 3 upon 61. Now the next example is 2x plus I cube into y in bracket 2 plus I, x into I raised to 7 plus 10 I raised to 16. Therefore, I raised to 9 means I into I raised to 8. I into I raised to 8 means what? I square and bracket raised to 8. Bracket raised to 8 must be there. Bracket raised to 4 must be there because the total power is 8. Therefore, I into I, 1 raised to minus, that is equals to I raised to 9 is equals to I raised to 7 is equals to, again, that is equals to minus I raised to 16 is equals to I square and bracket raised to 8, that is a minus 1 and bracket raised to 8, that is equals to 1. Now the given equation becomes 2x plus I raised to 9 into y in bracket 2 plus I is equals to x I raised to 7 plus 10 I raised to 16. Now we substitute the values, that is I raised to 9 means I raised to 7 means minus I, and I raised to 16 means 1. Therefore 2x plus 2yi plus I square into y, but I square is minus 1 into, therefore minus ix plus 10, and that's why you will get 2x minus y 2iy, that is equals to minus ix plus 10. Therefore 2x plus 2iy minus y plus ix minus 10 equals to 0. Now equate the real part first of all, that is the 2x minus y minus 10 plus an imaginary part, that is a x plus 2y into I, and that is equals to 0. Now equating the real and imaginary part, you will get, that is a 2x minus y minus 10 is equals to 0. Equating the real and imaginary part, separately, two x minus y minus 10 equals to 0 and x plus 2y equals to 0. This is the equation number, that is equation number 1 and 2. Now again we will change the equation number 1, that is that 2x minus y equals to 10 must be there. That is equals to 10. This is very simple way. Now multiply equation number 1 by 2, then and then the variable y will be the cancelled when we add the terms. That is the 4x minus 2y is equals to 20. This is equation number 3, and add these two equations, that is 4x plus x, that is the 5x is equals to 20. Therefore x is equals to 20 upon 5, that is equals to 4. Put x is equals to 4, that is put the value x is equals to 4 in the equation, that is the 4 plus 2y equals to 0. Therefore 2y is equals to minus 4 and y is equals to minus 4 upon 2, and that is equals to minus 2. Hence x is equals to 4 and y is equals to minus 2. Now the question number 3. Question number 3. Evaluate 1 minus I square bracket is to minus 15. Now this is very simple example. The value of the I square is minus 1 and plus 1 minus 1 get cancelled. You will get minus I raised to minus 15. Therefore minus I raised to minus 15, and it can be written as, that is minus I raised to 15. That is 1 upon, that is equals to minus 1 upon I raised to 15. Now we can split up it like this, I into I raised to 14, that is minus 1 upon I into I square raised to 7. I square is minus 1 raised to 7, and that overall minus minus will become plus, and we will get minus, that is 1 upon I. Now multiply n and d by I, that is 1 into I into I square, that is equals to overall, that is a minus I. Second one, I raised to 131, I raised to 49 is equals to I raised to, that is we want to find out its value. We will directly make the calculation I raised to 130 into I plus I raised to 48 into I, that is a I square in bracket, that is bracket raised to 65 into I plus I square bracket raised to 24 into I, and hence we can cancel it, that is a minus I plus I, and overall the value is 0. Find the value of x raised to 3 plus 2x square minus 3x plus 21 if x is equals to 1 plus 2i, and we will evaluate this type of the examples we have already finished in the exercise. X minus 1 is equals to 2i squaring on both sides, x minus 1 bracket square is equals to 2i and bracket square, x square minus 2x plus 1 is equals to 4i square, 4 into minus 1, that is x square minus 2x plus 1, and that will become minus 4, it will become plus 4, x square minus 2x plus 5 equals to 0. Therefore, x square minus 2x plus 5 and x raised to 3 plus 2x square minus 3x plus 21. Now multiplied with by x to the first term, then you will get the x cube. This type of the division we have finished in the 7th, 8th standard, also 9 in the 9th standard, and you will get the 4x square minus 8x plus 21. Now we require 4x square, therefore we multiplied by 4, therefore x plus 4, and minus sign, change the sign, therefore you will get the remainder is 1. Yeah, the polynomial is 1 there. By the division algorithm, we can write dividend is equals to divisor into quotient plus remainder, and the remainder is 1 here by this. Therefore, now x raised to 4 plus 9x cube plus 35x square minus x plus 164 if x is equals to minus 5 plus 4i. Now x is equals to minus 5 plus 4i, x plus 5 is equals to 4i, squaring on both sides, x plus 5 bracket square is equals to 4i bracket square, x square plus 10x plus 25 is equals to 16i square, and it is x square plus 10x plus 25, that is a minus 16, and it will become plus, that is a 25 plus 16, that is equals to 0. Therefore, x square plus 10x plus 41 equals to 0. Now the division is x square plus 10x plus 41, x raised to 4 plus 9x square, 9x cube plus 35x square minus x plus 164, x square plus 10x plus 40. Now we'll make the division. Multiplied with x square, then you will get x raised to 4 plus 10x cube plus 41x square. Now their subtraction, and you will get minus x cube minus 6x square minus x plus 164. Now multiplied with by minus x, and you will get minus x cube minus 10x square minus 41, that is minus minus will become plus, and that's why you will get 4x square plus 40x plus 164. 164 must be there. had written, that is a 164 is there. Now the subtraction, and see this, that is a 0, 0. Therefore the remainder is 0. Now again by the division algorithm, we have dividend is equals to divisor into quotient plus remainder. Therefore x square plus 10x plus 41 into the quotient, that is a x square minus x plus 4, and the remainder is 0. Therefore the value of the polynomial for x is equals to minus 4 for I is equals to 0. Now I am changing there, that is a for the first question answer. Now see this, again I will repeating the answer of this question. First division, now the value was 1. I had not written by the division algorithm. Now the next question, if you want to write, then write this. Now the same question you can write here also. I am repeating this question. Now the question number 2 series. Now you can write this. This is sample test for can you write if I had written in first, and then can you write when I scroll my page. If it is yes, then tell me. Now the question number 5. Find the square roots of minus 16 plus 30i. Let minus 16 plus 30i is equals to x plus yi or iy, where x and y belongs to the set of real number. Now squaring on both sides, we get minus 16 plus is equals to x plus yi bracket square is equals to x square plus y square I square plus 2xyi. I square is minus 1, that is minus 16 plus 30i is equals to x square minus y square plus 2xyi. Now here we will equate the real and imaginary part. Equating the real and imaginary part, separately, we get x square minus y square is equals to minus 16 and 2xy is equals to 30. Therefore, x square minus y square is equals to minus 16 and xy is equals to 30. 30 upon 2, that is a 15. And that's why y is equals to 15 upon x. Now substitute the value, that is x square minus y square is equals to minus 16. X square minus y means what? 15 upon x is equals to minus 16. And therefore simplify this, that is 225 upon x square is equals to minus 16. Now multiply on both sides by x square, that is x raised to 4 minus 225 minus 16x square, and that is x raised to 4 must be there. I had written x square. There is a small mistake by me. X raised to 4 must be there. Change it. X square in bracket x square plus 25 and minus 9 in bracket x square plus 25 equals to 0. X square minus 9 in first bracket and second bracket, x square plus 25, that's equals to 0. Therefore x square plus 25 equals to 0 or x square minus 9 equals to 0. X square is equals to minus 25 or x square is equals to 9. X square minus 25 is not possible, that is the square of the real number is not negative, and therefore x square is equals to 9. X is equals to plus or minus 3 when x is equals to 3. Y is equals to 15 upon 3, that is 15 upon 3 means y is equals to 5. X is equals to minus 3, that is 15 upon minus 3, that is a minus 5. The square root of, therefore the square root of minus 16 plus 30i is 3 plus 5i and minus 3 minus 5i, and it can be written in compact form, that is a plus or minus 3 plus 5i. Number 2, 15 minus 8i. Let root of 15 minus 8i is equals to x plus iy, where x and y belongs to set of real number. Squaring on both sides, we get 15 minus 8i is equals to x plus iy bracket square. Now squaring on both sides, that is x plus iy bracket square, x square plus iy bracket square plus 2xyi, that is x square minus y square plus 2xyi. Now here equating real and imaginary parts separately, you will get x square minus y square is equals to 15 and 2xy is equals to minus 8, xy is equals to minus 4, that is y is equals to minus 4 upon x. Therefore x square 16 upon x square, that is equals to 15. Multiply on both sides by x square, then you will get x raised to 4 minus 16 is equals to 15x square. Therefore x raised to 4 minus 16x square, x raised to 4 minus 15x square minus 16 is equals to 0. You will get the factors minus 16 and plus 1. Therefore x square minus 16 equals to 0, or x square plus 1 equals to 0. X is equals to plus or minus 4 and x square is equals to minus 1 again. The square of the real number is not negative, and hence x square is equals to minus 1 is not possible. X square is equals to minus 1 is not possible. Therefore x is equals to plus or minus. When x is equals to 4, then y is equals to minus 4 upon x. Substitute the value of x is equals to 4, then you will get minus 1. And x is equals to minus 4, you will get now plus 1. Therefore, the square roots of 15 minus 8i are 4 minus I and minus 4 plus I. That is a plus or minus 4 minus I. Now next is a 2 plus 2 root 3i, that is equals to in root of 2 plus 2 root 3i is equals to a plus bi. Squaring on both sides, 2 plus 2 root 3i is equals to a plus bi bracket square. Therefore a square plus bi square, b square I square plus 2abi. I square is minus 1. That is a 2 plus 2 root 3i is equals to a square minus b square plus 2bi. A square minus b square is equals to 2, and 2 root 3 is equals to 2ab. 2 get cancelled. Equating the real and imaginary part. Now again the value of b is equals to root 3 upon a. Substitute the values. All these type of the examples I had finished number of the times, but still some students says number of time that sir upload the miscellaneous. I had taught each and every examples by considering a simple examples, simple way, so that all the normal student can understand this. The factors are a square minus 3 in first bracket, second bracket a square plus 1 equals to 0. Therefore a square minus 3 equals to 0, or a square plus 1 equals to 0. a square is equals to 3 or a square is equals to minus 1. Again, the square of the real number is not negative. Therefore, a square is equals to minus 1 is not possible. Therefore, a square is equals to 3, a is equals to plus or minus root 3, b is equals to root 3 upon a, and we will take first of all the value of a is root 3. When a is root 3, b is equals to root 3 upon root 3, and that is equals to 1. And when a is equals to minus root 3, therefore b is equals to root 3 upon a, that is minus root 3 upon root 3, that is equals to minus 1. b is equals to minus 1. Two plus 2 root 3I, the roots are root 3 plus I minus root 3 minus I, that is plus or minus root 3 plus I. These are the roots. Now next is fourth one, 18i. 18i is equals to x plus iy, where x and y belongs to set of real number. On squaring on both sides, you will get 18i is equals to x plus iy bracket square. 18i is equals to x square plus 2xyi plus I square y square, x square minus y square plus 2xyi. Therefore, you will get x square minus y square. Equating the real and imaginary parts, x square minus y square is equals to 0 and 2xy is equals to 18, xy is equals to 9, and therefore y is equals to 9 upon x. Therefore, x square minus y square is equals to 0. Put the value x square minus 9 upon x bracket square is equals to 0. Now simplify this. X square minus 81 upon x square, that is equals to. Now simplifying, you will get x raised to 4 minus 81 equals to 0, and you will get in first bracket x square minus 9, x square plus 9 equals to 0. Therefore, x square minus 9 equals to 0 or x square plus 9 equals to 0. Therefore, x square is equals to 9 or x square is equals to 9 or x square is equals to minus 9. But the x square is equals to minus 9 again not possible because the square of the real number is not negative. Therefore, x square is equals to 9. Therefore, x is equals to plus or minus 3. And again, when x is equals to 3, then y is equals to 9 upon x, that is y is equals to 3, and when x is equals to minus 3, y is equals to minus 3, and therefore the roots of 18i are 3 plus 3i and minus 3 minus 3i, that is plus or minus 3 plus 3i. Now next is 3 minus 4i. Let a root of 3 minus 4i is equals to a plus ib, where a comma b belongs to set of real number. Now squaring on both sides, you will get 3 minus 4i is equals to a plus ib bracket square, a square plus 2abi plus ib bracket square. Therefore a square plus 2abi minus b square, and you will get a square minus b square plus 2abi, that is 3 minus 4i, that is a square minus b square is equals to 3, and 2ab is equals to minus 4, and the value of b is again, that is the b is equals to minus 2 upon a. Substitute the value. A square minus b square is equals to 3. A square minus 2 upon a bracket square is equals to 3. Now simplify this. A square 4 upon a square is equals to 9. A raised to 4 minus 4 is equals to 3a square, and a raised to 4 minus 3a square minus 4 equals to 0. A square minus 4 in first bracket, second bracket, a square plus 1 equals to 0. Now here a square is equals to 4, a square is equals to minus 1, but again a belongs to R, and a square not possible equals to minus 1. Therefore a square is equals to 4, a is equals to plus or minus 2, and again when a is equals to 2, b is equals to minus 2 upon, that is a minus 1. When a is equals to minus 2, then you will get b is equals to plus 1. Therefore the roots are Therefore, the roots are 2 minus I and 2 minus 2 plus I. Therefore, that is a plus or minus 2 minus I. Now, next is fifth one. 6 plus 8I. Let root of 6 plus 8I is equals to a plus ib, where a comma b belongs to set of real number. Squaring on both sides, therefore you will get 6 plus 8i is equals to a plus ib bracket square. 6 plus 8i, a plus ib bracket square means what? A square plus 2abi plus I square b square, that is 6 plus 8i, a square minus b square plus 2abi. Therefore, a square minus b square is equals to 6, and 2ab is equals to 4. 2ab is equals to 8. Therefore, ab is equals to 4. Therefore, b is equals to 4 upon a. Now substitute the value. A square minus 4 upon a bracket square is equals to 6. A square minus 16 upon a square, that is equals to 6. A square minus a raised to 4 minus 16 is equals to 6a square. A square a raised to 4 minus 6a square minus 16 equals to 0. A square minus 8, a square plus 2 equals to 0, and therefore a square minus 8 equals to 0, or a square plus 2 equals to 0. Therefore a square is equals to 8, or a square is equals to minus 2. Again, the square of the real number is not negative. Therefore, a square is equals to minus 2 is not possible. Therefore, a is equals to plus or minus root of 8. That is equals to a is equals to plus or minus 2 root 2. Now, when a is equals to 2 root 2, then the value of b is equals to 4 upon a, that is a 4 upon 2 root 2, that is a 2 upon root 2 multiplied, and then you will get that is a value is root 2. B is equals to root 2, and when it is when a is equals to minus 2 root 2, b is equals to 4 upon a, that is a minus 4 upon 2 root 2, that is a minus 2 upon 2 root, minus 2 upon root 2 multiplied with root 2 root 2, that is a minus 2 root 2 upon 2, 2 get cancelled, and b is equals to minus root 2. Hence, the roots are plus or minus 2 root 2 plus root 2i. Now, question number 6. Find the modulus and argument of each complex number and express it in the polar form. Now the first is 8 plus 59. Let z is equals to 8 plus 59. This is of the form a plus ib, where a is equals to 8 and b is equals to 15. It's a modulus, that is mod of z of, that is r is equals to a square plus b square, that is a 64 plus 15 square, that is r is equals to in root of 64 plus 225, that is in root of 289, therefore r is equals to 17. If theta is the amplitude, then cos of theta is equals to a upon r. Therefore, z is equals to x plus iy. Z is equals to 8 plus 59. Now we'll find theta, and always the value of the tan theta is y upon x, that is 15 upon 8, and that is equals to tan inverse of 15 upon 8. The polar form of z is equals to r in bracket cos of theta plus I times sin theta, r is 17, that is 8 upon 17 plus 15 upon 17i, that is 17 will get cancelled again, you will get z is equals to 8 plus 15i, where theta is equals to tan inverse of 15 upon 8. Next is number 2, 6 minus I. Let z is equals to x plus iy, where here x is equals to 6 and y is equals to minus 1. Z is equals to in root of x square plus y square, that is 6 square plus minus 1 bracket square 36 plus 1, that is the root of 37. If theta is amplitude, then tan theta is equals to y upon x, that is equals to minus 1 upon 6. Theta is equals to tan inverse of minus 1 by 6, that is a minus tan inverse of 1 upon 6. That is the tan inverse of minus theta is minus tan inverse of theta. That is a tan theta is equals to minus tan inverse of 1 upon 6. Therefore, polar form of z is equals to r cos theta plus I times sin theta. Z is equals to root of 37 in bracket cos of theta plus I times sin theta. That is a root of 37 in bracket cos of theta is x upon r, and the value of x is 6 upon root of 37. Sin theta is equals to y upon r, that is minus 1 upon root of 37. The polar form root of 37 in bracket 6 upon root of 37 minus 1 upon root of 37 I into I. Third one. Now number 3. 1 plus root 3i upon 2. Z is equals to 1 plus root 3i upon 2. That is equals to 1 upon 2 plus root 3 upon 2i. Root 3 upon 2 into I. Z is equals to x plus iy. X is equals to 1 upon 2. Y is equals to root 3 upon 2. Therefore, r is equals to in root of x square plus y square. That is 1 upon 2 bracket square root 3 upon 2 bracket square. And that is equals to r is equals to 1 by 4 plus 3 by 4. And that is equals to 4 upon 4, and that is a 1. Therefore, r is equals to 1. Now, next is cos theta is equals to x upon r. That is 1 upon 2 upon 1. That is equals to 1 upon 2. Sin theta is equals to y upon r. That is a root 3 by 2 upon 1. Sin theta is equals to root 3 upon 2. Also, tan theta is equals to y upon x. Therefore, root 3 upon 2, 1 upon 2, you will get a root 3. Now to find the value of this theta, that is a tan theta is equals to root 3. Here the given point xy lie in the first quadrant. Therefore, this is very simple angle, and the angle is pi by 3. That is theta is equals to tan inverse of root 3, that is equals to pi by 3. Therefore, the polar form z is equals to r cos theta plus I times sin theta. equals to 1 in bracket cos of pi by 3 plus I times sine of pi by 3. Z is equals to 1 in bracket cos of pi by 3 plus I times sine of pi by 3. Next is minus 1 minus I upon root 2 and split up it. That is minus 1 upon root 2 minus I upon root 2. X z is equals to x plus iy. X is equals to minus 1 upon root 2. Y is equals to minus 1 upon root 2. Points minus 1 upon root 2 minus 1 upon root 2. These lie in the third quadrant. In third quadrant, therefore cos theta is equals to x upon r, that is minus 1 upon, now r is equals to, well, we do not have to find the value of r. R is equals to in root of x square plus y square, that is minus 1 upon root 2 square plus minus 1 upon root 2 square, then you will get 1 upon 2 plus 1 upon 2. Therefore r is equals to 1. Cos theta is equals to x upon r, that is minus 1 upon root 2 upon 1, that is a minus 1 upon root 2. Sin theta is equals to y upon r, that is 1 upon minus 1 upon root 2 upon 1, that is a minus 1 upon root 2. Now these 2 points lie in the third quadrant. Now how to decide this? Now in the textbook we have given, that is the theta is equals to pi plus tan inverse of 1. Therefore theta is equals to, now see this, tan inverse of theta, tan inverse of 1, and that is, now I had taken there because the point lie in the third quadrant, therefore theta is equals to tan inverse of 1 plus pi. This is given in the chart in the textbook. When x and y both are negative, theta is equals to tan inverse of theta plus pi. Theta is equals to 5 pi by 4. The polar form of z is equals to r cos theta plus I sin theta. The value of r is 1. Cos of 5 pi by 4, I times sin of 5 pi by 4, bracket complete. Now fifth one, 2i. Let z is equals to x plus iy, 0 plus 2i when x is equals to 0 and y is equals to 2. Therefore r is equals to in root of x square plus y square, that is a 0 plus 2 square, that is equals to 4 plus equals to 2. R is equals to 2. Therefore sin theta is equals to y upon r, that is a 2 upon 2, that is 1, and cos theta is equals to 0 upon r, and that is equals to 0. Now this very simple thing, the point lie on the y-axis and it is on the positive y-axis, I always say, because above the x-axis it is the positive y-axis, below the x-axis it is the negative y-axis, and it's clear that the theta is equals to pi by 2. Sin theta is equals to 1 and cos of theta is equals to 0. The point lie on the positive y-axis. Also tan of theta is equals to y upon x, and we get the not defined, that is therefore theta is equals to pi by 2. Z is equals to r cos theta plus I times sin theta, 2 cos pi by 2 plus I times sin of pi by 2. This is polar form. Now next is one, that is a 3i. Now z is equals to x plus iy, 0 minus 3i. The value of x is 0, y is minus 3. Point lie on negative y-axis, and it's clear that their argument is 3 pi by 2. Now r is equals to in root of x square plus y square, that is in root of 0 square plus minus 3 bracket square. R is equals to 3, sin theta is equals to y upon r, that is a minus 3 upon 3, that is equals to minus 1, and cos theta is equals to y x upon r. The value of x is 0 upon 3, that is the cos of theta is equals to x upon r. Tan theta is equals to, now the tan theta is equals to y upon x. Here the point is on negative y-axis. Now see this, that is 3 pi by 2. Therefore z is equals to 3 in bracket cos of 3 pi by 2 plus I times sin of 3 pi by 2. Seventh, minus 1 upon root 2 minus 1 upon root 2i. Z is equals to minus 1 upon root 2 minus 1 upon root 2i. X is x plus iy. X is equals to minus 1 upon root 2, y is equals to minus 1 upon root 2. R is equals to in root of x square plus y square, that is 1 upon root 2 minus 1 upon root 2 bracket square plus minus 1 upon root 2 bracket square. Therefore R is equals to 1 upon 2 plus 1 upon 2, and that is equals to 1. Sin theta is equals to minus y upon r, and cos theta is equals to x upon r. The value of y is minus 1 upon root 2 upon 1. And y is equals to minus 1 upon root 2. Therefore, sin theta is equals to minus 1 upon root 2 upon 1, and cos, that is minus 1 by root 2. Cos theta is equals to y upon r, that cos theta is equals to x upon r, that is a minus 1 upon root 2 upon 1, that is a minus 1 upon root 2. Therefore cos theta is equals to minus 1 upon root 2. Now here both sin and cos both are negative, therefore the point lies in the third quadrant, and tan theta is equals to y upon x, that is equals to 1, and again x is negative, y is negative, and that's why theta is equals to pi plus tan inverse of 1, that is a pi plus pi by 4. Pi by 4, and that is equals to 5 pi by 4. Theta is equals to 5 pi by 4. Now next is represent 2 plus I, 2 plus 1, sorry 1 plus 2i, 2 minus I, minus 3 minus 2i, minus 2 plus 3i by the points in Argand diagram. Now the first point is z1, which is 1 plus 2i. Now you draw the graph on the graph paper. I had drawn here roughly here. That is a Z1 1 plus 2i. Note the points 1, 2, 3 on the both axes. 1, 2. Next point is 2 minus I. That x is 2 and y is minus 1. Therefore, that point is in the fourth quadrant. X is 2 and y is minus 1. Z3 is equals to minus 3 minus 2i. The point is in the third quadrant. Point is in minus third quadrant. Z3 is a minus 3 minus 2. Z4 is equals to minus 2 plus 3i. X is negative and y is positive. It is in the second quadrant. X is negative, y is positive. And in this way, we have drawn that Argand diagram. Now show that Z is equals to 5 upon in bracket 1 minus I into 2 minus I into third bracket 3 minus I is purely imaginary number. This is very simple. This type of examples also we have solved in our exercise. One minus I, 2 minus I, 3 minus I, that is equals to their multiplication 1 minus I, and now we will perform here the product 2 minus I into 3 minus I. Now see this here, 1 minus I, 6 minus 2i minus 3i plus I square. I square is minus 1, that is a 1 minus I, 6 minus 5i minus 1, and in bracket you will get 1 minus I, that is a 5 minus 5i. If you take the 5 common, then you will get 1 minus I into 1 minus I, that is 5 in bracket 1 minus I bracket square, and we will expand it 1 square minus 2i plus I square. Therefore, you will get 5 in bracket 1 minus 2i minus 1 plus 1 minus 1 get cancelled, and then you will get minus 10i. That is 5 upon in bracket 1 minus I, 2 minus I into 3 minus I, and that's equals to 5 upon minus 10i. Now simplify this. 1 upon minus 2i multiplied numerator and denominator by I. Therefore, you will get minus I upon 2i square. I square is minus 1, and that is equals to I upon 2, where which is purely imaginary, and hence it is approved. Now next is question number 9. Find the real number x and y such that x upon 1 plus 2i plus y upon 3 plus 2i is equals to 5 plus 6i upon minus 1 plus 8i. Now normal simplification is there. That is it. First is cross multiplication, that is x in bracket x plus 2i plus y in bracket 1 plus 2i upon 1 plus 2i into 3 plus 2i, that is equals to 5 plus 6i minus 1 plus 8i. Now their multiplication, 3x plus 2x, 2ix plus y plus 2iy. Now in first bracket 1 plus 2i, in second bracket 3 plus 2i, their multiplication, I square is minus 1, that is a minus 4. 3x plus y plus 2x plus 2i, bracket complete into I, 3 plus 8i plus 4 in bracket minus 1, 5 plus 6i minus 1 plus 8i. Now perform their multiplication, that is a 3x plus y plus 2x plus 2y into I, that is equals to that is a 3 plus 8i minus 4, 5 plus 6i minus 1 plus 8i, 3x plus y, 3, that is in the next bracket 2x plus 2i into I upon minus 1 plus 8i, that is equals to 5 plus 6i upon minus 1 plus 8i. Now minus 1 plus 8i to the denominator on the both sides get cancelled and you will get. Now equate real and imaginary part, that is the 3x plus y is equals to 5 and 2x plus 2y is equals to 6. Now multiplied equation number 1 by 2, then you will get, that is a 6x plus or subtraction, sorry, that is a equation 1 minus equation 2, 3x plus y is equals to 5x plus y is equals to 3, and their subtraction. Therefore 2x is equals to 2x is equals to 2 upon 2, x is equals to 1. Therefore x is equals to 1. Put x is equals to 1 in equation 2. Therefore y is equals to 3 minus 1, that is equals to 2. And we have the values x is equals to 1 and y is equals to 2. Number 10. Example, we are taking the 10th example, not 9. Show that 1 upon root 2 plus I upon root 2 bracket raised to 10 plus 1 upon root 2 minus I upon root 2, that bracket raised to 10 equals to 0. I am taking the 10 examples and not 9. That is 1 upon root 2 plus I upon root 2 bracket square. Now see this, how this type of example is solved. First of all, we make the square term, that is 1 upon root 2 plus I upon root 2, square this bracket, and after the simplification you will get, that is 1 upon root 2 plus I upon root 2 bracket square is equals to I. Now we have the bracket raised to 1 upon root 2 plus I upon root 2 bracket square and whole bracket raised to 10 is equals to 1 upon root 2 plus I upon root 2 bracket square and whole raised to 5, that is a I raised to 5, that is equals to I raised to 5, and it is written as like this. Now next is, we will find out the value of I raised to 5. 1 upon root 2 minus I upon root 2 bracket square. Now expand this. Therefore, you will get 1 upon 2 minus 2i upon 2 minus 1 upon 2. Overall, it is a minus I. Now, this is the bracket square, which is minus I. Therefore, 1 upon root 2 minus I upon root 2 bracket raised to 10 is equals to 1 upon root 2 minus I upon root 2 bracket square and whole bracket raised to 5. That is minus I raised to 5, which is minus I raised to 5. Therefore, I upon root 2, 1 upon root 2 plus I upon root 2 bracket raised to 10 plus 1 upon root 2 minus I upon root 2 bracket raised to 10 is equals to I raised to 5 minus I raised to 5, and that's equals to 0. There are the 10 examples. The value is, it's approved. Now, next example. Number 2. Second one. Show that 1 plus I upon root 2 bracket raised to 8 minus 1 minus I bracket raised to 8 upon root 2, that is equals to 2. Now, this is the 11th examples because the numbers in the textbook given are wrong. Therefore, I had corrected it. This is the 11th example. Split up it and square it. 1 upon root 2 bracket square plus 2, 1 upon root 2 into I upon root 2 plus I upon root 2 bracket square. 1 upon 2, 2I upon 2, I square upon 2, that is 1 upon 2, I minus 1 upon 2, and that is equals to I. Therefore, 1 upon root 2 plus I upon root 2 bracket square is equals to I. Therefore, 1 by root 2 plus I upon root 2 brackets raised to 8 is bracket raised to 8 is equals to 1 upon root 2 plus I upon root 2 bracket square and raised to 4. Therefore, it's I raised to 4 and I raised to 4 I square, and that is equals to minus 1. Therefore, there must be the plus 1, that is 1 upon root 2 plus I upon root 2 bracket raised to 8 is equals to plus 1 must be there. I will change it shortly. Next is 1 minus I upon root 2 bracket square is equals to 1 upon root 2 minus I upon root 2 bracket square. Now expand this. Now simple expansion, that is 1 upon 2 minus I plus I square upon 2. Overall you are getting its value is minus I. Therefore, bracket raised to 8 is equals to 1 minus I bracket raised to 2 and whole bracket raised to 4, that is minus I raised to 4, that is equals to, now I am changing its value, that is 1, and overall you will get I square bracket square, and that is equals to 1. And there is a small correction in the textbook, that is there is a plus sign between that two terms and not minus sign. Therefore, 1 plus I upon root 2 raised to 8 plus sign is there, plus 1 minus I root 2 bracket raised to 8, and that is equals to 1 plus 1 equals to 2. Sometimes there is a problem when the examples given in the textbook is wrong, is wrongly printed. Therefore, the answer is that is equals to 2. It is approved, and in this way we have completed up to the question number 11. Now we'll see in the next video. Till then, goodbye. In this way we have completed the question number 2 to 19. I hope that you have understood all the questions, whatever I had explained. And also, if you are new for this channel and if you like this my work, then subscribe it and share it with your needy friends. Now we'll see in the next video. Till then, goodbye.